Let us start the last lecture on this exercise 3.3 from integration by parts. Integrate the following functions with respect to x. One plus cot x minus cosec square x into e raised to x. As soon as you see e raised to x in your integrand, just think of the corollary e raised to x in bracket f of x plus f dash of x dx. E raised to x in bracket 1 plus cot x plus minus cosec square x. So here, if you take the derivative of e raised 1 plus e raised 1 plus cot x, you will get minus cosec square x. So if we take f of x as 1 plus cot x and f dash of x as minus cosec square x and use the formula integration of e raised to x in bracket f of x plus f dash of x dx is e raised to x f of x plus c. So I is equal to e raised to x in bracket 1 plus cot x plus c. Now the second example, 1 plus sin x upon 1 plus cos x e raised to x. Again here it is e raised to x into something. So you have to just simplify these so that you can write this as a function and its derivative. So 1 plus cos x I can write it as 2 cos square x by 2. This sin x I can write it as 2 sin x by 2 cos x by 2. So here after dividing the separate 1 upon 2 sec square x by 2 plus this 1 cos will cancel, this 2 also will cancel, sin x by 2 upon cos x by 2 is tan x by 2. So here we have to take f of x as tan x by 2 and f dash of x as 1 half sec square x by 2. And again we will use the same corollary, integration of e raised to x in bracket f of x plus f dash of x dx is equal to e raised to x f of x plus c. That is I is equal to in e raised to x tan x by 2 plus c is the integral of the given function. Now e raised to x in bracket 1 upon x minus 1 upon x square. Clearly easily you can identify what is f of x and what is f dash of x. Okay, so this is your f of x and its derivative is this. So f dash of x is minus 1 upon x square. So it is in the form of e raised to x in bracket f of x plus f dash of x. So its integral is given by e raised to x f of x. So what is f of x? 1 upon x. So e raised to x 1 upon x plus c. Now here x upon 1 plus x bracket square dx. If you see, denominator contains 1 plus x, but in numerator there is no 1 plus x, so we have to create 1 plus x. So add 1, subtract 1, then divide this 1 plus x square by separately. One factor will cancel and you get 1 upon 1 plus x plus minus 1 upon 1 plus x square. So this is your f of x and its derivative is minus 1 upon 1 plus x bracket square. Use the corollary, e raised to x in bracket f of x plus f dash of x dx is e raised to x into f of x plus c. So I is equal to e raised to x in bracket upon 1 plus x plus c. Now the next example is what is the next example? E raised to x upon x in bracket x log of x bracket square plus 2 log of x. Now here we can't see anything like the corollary e raised to x f of x plus f dash of x, but e raised to x is there. And each of these, if you see, these are the composite functions. Log of x something square, log of x bracket square. So we use the substitution log of x bracket square x log of x bracket square plus 2 log of x. This divide this x to this bracket. This x will cancel and here you will get 2 log x upon x. So log of x, it's a square, its a derivative is nothing but 2 log x upon x. So again we use the same corollary to write the answer of this problem. Now cosec log x into 1 minus cot of log x. Here it is a composite function. So we cannot directly use the corollary. So use the substitution log of x is equal to t. So 1 upon x dx is dt, or log of x is equal to t is the logarithmic equation. So its corresponding exponential equation is x e raised to t. So dx is equal to e raised to t dt. Use that value here. Then you will get e raised to t in bracket cosec t minus cosec t quad t, that is cosec t is as it is plus minus in bracket cosec t quad t. F of t is cosec t and f dash of t is minus cosec t quad t. So e raised to x f of x plus f dash of x dx, its integral is given by e raised to x f of x plus c. So you get e raised to t cosec t plus c. But again, what is t? T is nothing but log of x. So e raised to log of x is nothing but again x. So x cosec log of x plus c is the solution of the given problem. So here e raised to phi x into phi x plus phi x log x plus 1 upon x. Here also we have to use the substitution, put phi x is equal to t. So phi dx is dt. So dx is equal to dt upon phi. So the integral will be reduced to this form, e raised to t in bracket phi log of t by phi plus phi upon t. Take 1 upon 5. Here if you multiply this 1 upon 5 to this bracket, this 5 will cancel and this 5 also will cancel, and you get e raised to t log of t by 5 plus 1 upon t. So f of t is log of t by 5, and f dash at t is 5 upon t into 1 upon 5, that is 1 upon t. So using e raised to x f of x plus f dash of x dx, its integral is given by e raised to x f of x plus c. So it's the problem, integration of the given problem is e raised to t log of t by 5. But again, what is t? T is 5x. So e raised to 5x log of 5x upon 5 plus c, that is e raised to 5x log of x plus c is the solution of the given problem. The next problem is e raised to sine inverse of x in bracket x plus root x 1 minus x square upon root 1 minus x square. Here use the substitution sine inverse of x is equal to t. So x is equal to sine t, and 1 upon root 1 minus x square dx is dt. So your problem will reduce to the step e raised to t sine t plus cos t dt. So it is in the form of e raised to t f of t plus f dash of t. Use that formula, you will get the answer e raised to t sine t. But what is t? T is sine inverse of x. So sine of sine inverse of x plus c, e raised to sine inverse of x into x plus c. Now log of 1 plus x bracket raised to 1 plus x. Use the logarithmic property of the log. We can take the its 1 plus x into log of 1 plus x. Then use the substitution log of 1 plus x is equal to t. You get 1 plus x is equal to e raised to t. So dx is e raised to t dt. So e raised to t into e raised to t dt. So you get t into e raised to 2t dt. So use by LIATE by parts formula. First function as it is, integration of the second function minus integration in bracket derivative of the first function into integration of the second function. So t into e raised to 2t upon 2 minus integration of the derivative of 1 is the derivative of t is 1, and derivative of integration of e raised to 2t is e raised to 2t upon 2 dt. So again we got the integral of e raised to 2t is e raised to 2t upon 2. So simplify, taking 1 by 4 e raised to 2t common, you get e raised to 2t into 2t minus 1 plus c. But what is t? T is log of 1 plus x. So we substitute that e raised to 2 times log of 1 plus x upon 4 into 2 times log of 1 plus x minus 1 plus c. This we can write it as e raised to log of 1 plus x bracket square, that is 1 plus x bracket square upon 4 is equal into 2 times log of 1 plus x minus 1 plus c. So this is all about the exercise 3.3 from by parts. In next lecture we will study partial fractions.